Hi, it's Jason here again at the Centre for Computing History, and I've got the pleasure of being with Duncan Smeed.
Hello.
Hello, of Dragon and Dragon Data, I should say, is the proper name, is that right?
Yes, I
Right.
work for Dragon Data.
Right, cool. Well, so what was your job title there?
System software manager.
Right, okay.
So my responsibility was the system software, the BIOS, the I/O side of things.
The low-level stuff.
And of course, Microsoft provided the basic
Right.
interpreter. So I was flown across to Microsoft for the day
Oh,
to pick up the, the image from them.
all right.
So that was quite interesting.
Did you have to modify that image, or was that an image that they had worked
No,
on?
basically, they provide the interface that you need to provide from the BIOS point of view. So there's an API, the programming interface. So we had to write the BIOS routines, and so they would interface with that. And so they had the basic package that they could port to any architecture, really.
Right. So, I mean, the very first Dragons had a Microsoft Basic on them. So
Yes,
you
yeah.
you were there at the ground level. You were there from the very beginning.
At the very beginning, I was still working at the University of Strathclyde in the Department of Computer Science, and Motorola, East Kilbride were contracted, if I recall correctly, to actually help with the design, because the Dragon was a reference design 6809 processor, which is a great processor, and the 6847 video processor. And so if you looked at the 6809 and 6847 of the day, then essentially it was a reference design, and the Tandy color computer was basically an implementation of that reference design. And Dragon Data, it was before Dragon Data, it's really Metoy that started the whole process off.
Okay.
And they used PA Consulting here in Cambridge to do the hardware design. Motorola was involved because obviously they're selling the 6809, 6847 chipset.
Yep.
And East Kilbride had good contacts with the University of Strathclyde Computer Science Department with a colleague of mine, and he knew that I was quite an accomplished 6809 assembly language programmer.
Right.
And so he said to Motorola, you should have a word with this guy. And so I was a consultant, so I didn't actually start working for Dragon until after they started manufacturing the Dragon, and after I'd consulted and implemented the BIOS for them. And then Dragon decided that they needed in-house expertise rather than relying on consultants. So they made me an offer I couldn't refuse.
Right.
So I joined them.
Fantastic.
Yeah.
When was this?
This would be in about 83,
Right.
82, 83. I moved down to Bridgend, lived in Bridgend. My daughter was born in Bridgend in 84, so it's fond memories of Wales.
Fantastic.
Yeah.
Fantastic. So we've got a couple of machines here. Can you tell us a little bit about what we've got? Because probably should say this is part of a Dragon Day that we've got here at the museum. And we've seen all sorts of weird and wonderful machines out there. Dragon's a really interesting computer, really. It's a difficult one to collect because beyond the Dragon 32, they're very rare.
Yes.
But it's actually, it is much more than Dragon 32.
It's interesting. I have to say that I feel like I'm a bit of an imposter because I have never really been enthusiastic in terms of keeping my Dragon alive and using it and programming it and so on. So I've moved on from Dragon. And so essentially the Dragons went into the attic or into my office at university, because then I would bore my students to death by talking about the real world. And I remember one time I was a mature student in my class. I'd just returned from industry, from Thorn EMI and Dragon Data. I was talking about the real world, and it was quite interesting because I could see she bristled every time I said that, until eventually she cracked and her hand shot up and she said, "Duncan, you're always talking about in the real world. I've been in the real world. I've never met anyone like you there." that was quite amusing. And I had quite a good lecture after that as I addressed that particular criticism of me.
It's one of those things, though. That it's people do go to university and educational places and talk about how it is outside of the world of university.
Yeah, and if any of my students are watching this video on YouTube, they will remember that story, because every cohort of students would get that story as an icebreaker.
Yeah, no, absolutely, absolutely. Yeah. Well, if anybody does remember it, put it in the YouTube comments below, and it'd be nice to see. So back to the machines.
Okay, so this is the very first Dragon that breathed fire.
Right.
So this is the prototype.
Nice, a prototype Dragon.
The very first Dragon that worked.
So this is a Dragon 16, then, the 16K of memory.
Yeah, right. And of course they had to up the memory because they had to compete against the sort of, the Sinclair products and so on. And so I think they piggybacked an extra 16, so it became the Dragon 32. Yep.
We have one of those in the museum. So, piggyback board there, another banker RAM on it.
Yeah.
So the early ones did.
So this prototype doesn't really look very much like the final circuit board for the Dragon, because obviously PA Consulting, as you can see, that it's very much a prototype.
Yeah, no silk screen.
And the EEPROMs, so these are the EEPROMs that will be programmed just to make sure that the BIOS worked and interface with the cassette and the keyboard and so on.
Are they 4K ROMs or 2K ROMs or something like that?
Something like that, I can't remember actually.
24-pin chips anyway.
Yeah.
6809 over here.
Yeah. 6847, which is video side of things.
And this was always quite interesting because you had the UHF modulator and power supply on this little separate board. It's it's interesting. I mean, you mentioned the relationship with the university, which is actually kind of a Cambridge story as well. Acorn very much used the university and used the talent that was there. So same kind of story. So that's really incredible. So there are very few there. So a board without any kind of solder resist and overlay and silk screen and things like that. This is clearly
sort of a one-off.
Low production.
So I could prove the BIOS.
Let's very carefully turn it over. Oh, a couple of mods.
Yeah, as always.
Absolutely.
It wouldn't be a prototype without mods.
Absolutely. So fantastic. Pippin there. Is that?
Yeah, that's the prototype name.
Right. There you go, prototype of the Dragon 32 or 16 as it was at this point. Prototype named Pippin, right, okay. So, and keyboard, which we recognise from the normal Dragon that we see. So that's fantastic. So there's probably only one of these, is there, that you know of?
I'm not aware of any others.
Right. We'll put it down very, very carefully there. But fantastic stuff. So let's move over to this board we have over here.
Yeah.
So
this is the Dragon Alpha board.
So tell me about the Dragon Alpha.
Well, that's interesting because I don't really recall that much. The Dragon Alpha, we wanted to make something that's more business oriented, to run OS 9, because OS 9 is a really nice operating system, some really nice pieces of software for it. And so, the Dragon Alpha came after the Dragon 64. It's quite interesting, it's got dual 6809s on it, and people often ask why are there dual 6809s. And because OS 9 is essentially a multitasking operating system, you can't have I/O routines that poll for, have you finished transferring that data. So you have to have what's called a DMA, a direct memory access controller, to actually offload from the processor the moving of data between the I/O devices and memory. And I remember meeting with, I think the guy's name was Ken Kaplan of Microware, and we had a technical meeting talking about, the Dragon Alpha. And he said, well, you'll need a DMA controller, and of course that means, that's more expense. And so I said, well, listen, we've got lots of 6809s in stock. I can create a DMA controller from the 6809. So The second 6809 just sits there waiting for interrupts.
Right.
And then it's got a small routine that I wrote, which is basically just copy bytes from one place to the other.
Right.
So it's a DMA controller. And we
Ingenious.
could use, we had plenty of 6809s.
Yeah.
So we just used another one.
Right.
Yeah.
That's quite ingenious. So it's probably got RAM and ROM that sit with it.
Yeah.
So it's his own little micro there.
Its own
just doing the job
micro,
of a DMA.
yeah, just using a small routine, waiting for interrupts, and then when it's finished its transfer, it just goes back to sleep.
Right. Yeah. And probably DMA chips were relatively expensive. Would using a few of those chips together equate to the same kind of price? Or is it just pure convenience and getting the job done quickly?
Get the job done quickly, using the products we had and the emulators and things that we had and the experience we had. So yeah, it was a no-brainer. Yeah, why not use another processor?
Absolutely. Yeah. It's those kind of stories that I like. You know, finding other ways to do the same job.
You've got to think outside the box. Occasionally. Yeah.
No, absolutely.
And I was quite proud of that.
Yeah.
That's another story I give my students at university.
Right. You should be. It's a big outside the box. Finding other ways to do things. Yeah. I mean, that's what engineering is about. Yeah. You know, anybody, I say anybody, but anybody could design a product for any amount of money. But it takes somebody with engineering skills to design it down to a price or to a size. And
yeah, so, you know, lots of little tweaks like that, sort of making use, because obviously you're writing code to be as efficient as possible, especially when you're doing the BIOS and it's doing I/O. So I remember that the keyboard routines were actually faster because the PA consultant put, you know, a small hardware tweak in it, which meant that I could scan the keyboard in a slightly different way, using sort of bit shifting and bit twiddling. And because that was done by polling rather than interrupt, it meant that our basic ran faster than the basic on a Tandy color computer. So it's a faster computer, primarily because the keyboard scanning routine was more efficient. Right. So that's another thing I was quite proud of.
Yeah, that's interesting.
Yeah. But the hardware guys take the credit for realizing that, yes, what we could do is make it a wee bit faster like that.
Right. Yeah. Fantastic. Yeah. So tell me about PA consulting, because that tweaks my interest. So we're talking about a Welsh machine that has is designed the wrong word, or you know, was it just the board design, or how did PA consulting
well, I don't know, because remember I was just brought on as a consultant, so I wasn't working for, it was Metoy at the time, and Metoy wanted to diversify from sort of die cast things. So,
stuff,
you know, somebody had the vision within Metoy to think about the home computer market. So they would have to go out because they had no in-house expertise.
Skills in that area, right. Yeah.
And PA consulting. I don't know how they won the contract, what have you, but I did go out and meet them once. I came down to Cambridge to meet them. We talked about the implementation and the BIOS, and talked about like keyboard scanning routine and stuff like that. So
I'm just wondering whether we can claim this as another Cambridge machine.
Well, from the point of view of you know, the hardware, yes, PA consulting took the reference design and implemented it. Yeah.
Good stuff. So in terms of what you were doing in developing the code, the low-level I/O stuff, physically, what was that? How did that go about? I mean, did you have in-circuit emulation and all the tools to do it, or was it done, were you hand coding?
Oh, hand coding. Everything's hand coded.
Right.
So, you know, the cassette interface, because obviously you have an analog, digital to analog converter, so you're taking the digital signals and you're creating the acoustics.
The audio waves,
audio waves for the thing, you know, scanning the keyboard and various bits and pieces. So
and that kind of thing's all done just by a
bit twiddling.
A cleverer version of trial and error?
No, I didn't have an emulator or anything like that at the time, so just basically, you know, this is what needs to happen. And
but so if you've got a waveform and it needs to be sort of 300 hertz or whatever it might be, you work out the speed of the processor, how many clock cycles it's going to take to toggle this at that.
You're doing a lot of clock counting and stuff like that. A lot of it will be data driven, of course, because you're not going to generate it, you're just going to read the data from a ROM image, which basically will give you wave patterns and so on.
Right.
It's been a while, so I'd need to look at the listing again to make sure.
I'm not going to ask any more detail, but it's just because a lot of these things were developed in a way that seems quite alien to a lot of people today that are
absolutely,
creating software, creating hardware.
Well, the 6009 was a lovely processor. It's a really elegant 8-bit processor, much better in my opinion, and most people's opinion that know anything about it, than a 6502 or a Z80 or an Intel 8080. And it's still one of my favorite processors.
Yeah.
And, you know, I was fairly knowledgeable about it, so that's why Ian Somerville and I wrote the definitive book about the inside
yes,
the
we
Dragon.
should say this video is promoting Duncan's latest book.
It probably was my latest and only book. Yes, yeah.
Inside the Dragon, and Duncan Smeed and Ian Somerville.
Yeah. And Ian, of course, was a very highly regarded software engineer because he's really written the definitive textbook on software engineering, so he was well regarded. Right. So he and I decided that I would write the technical side of things and he would use his writing skills to package it and so on. Right. So, you know, it was a joint effort between myself and Ian. Right. And
now it's kind of considered the techie Bible, isn't it, really?
Apparently, people have been asking me to sign copies today.
Oh yeah, we should do that. Yeah. We should get you signed out. Oh, I'm glad you reminded us. So, in terms of the Dragon and its history and things that might have happened there, is there anything you can remember specifically that?
Oh, it's quite interesting because I was flown to Seattle for the day to go and pick up the basic image from them. So I was shown around, you know, and this was, you know, in the early 80s, in the early days of Microsoft. So I think they only had about one office building on the campus and only several hundred people who worked for them. And, you know, working in cubicles and, you know, sort of blankets around their shoulders. So you knew that they were working hard and working almost 24/7 on things.
And mostly at that time because people wanted to. You know,
yes,
a lot of engineers and you know, it's just driven by passion.
Yeah. And, you know, in the early days, probably only several hundred Microsoft employees at the time. To a certain extent, I regret turning down a tentative job offer from Microsoft at that time, because I would have been one of the first few hundred Microsoft employees. But hey, I enjoyed what I do.
We'll make our choices.
Yeah, we make our choices. I don't regret it.
You can't, can you? You can't go back and change anything.
And I met Bill Gates as well.
Fantastic.
Which was interesting.
Yeah. Interesting.
And, quite interesting.
Tell us about that.
Well, I didn't have very long conversations with him. It was just nice to meet him. He said, "Oh, you know, you're working and you're going to do, you know, the Dragon, and you're using Microsoft Basic." So, and you know, I would ask him one or two questions, and if the question wasn't well received or he disagreed with what you were saying, then he would sort of say, "So what?"
Right.
Which was, you know, I think that was just a way of saying, "Okay, we're established. You know, we're here. It doesn't really matter what other people think."
Right.
So
he's quite an intense person.
Oh
to,
yes,
to talk to.
I didn't have long conversations with him. A bit later on, when I was working for Thorn EMI, we were working on the idea of a portable PC. And I went to Seattle again, and this was for the very first Windows conference, Windows 1.0. And that's where I had a bit longer of a conversation with him. So that's where most of my recollection comes from, of Bill Gates. But that was quite interesting. The very early Windows conference.
That's brilliant. It's got to be good to be able to say, yeah, you've had a chat with Bill Gates. That's fantastic.
He won't remember me.
You never know. You never know. The Dragon obviously sticks in lots of people's minds. So you may well do. Who knows? But plus, you can remember a lot of stuff as well, from what I hear.
Yeah.
But anyway, so so that's fantastic. So I mean, you've mentioned, and we are going to do another video about the Liberator. Moving on to Thorn EMI, so
right.
we'll do something separate on that.
Oh, cool.
But did you come from Dragon and into Thorn EMI, or was there what was going on between the two?
It was quite interesting because obviously Dragon was known as a home computer manufacturer, and we were in some respects regarded in the same sphere as Acorn, Sinclair, and what have you. Now, I don't exactly know the details. There's a really good background article in the Register written by Tony Smith, who's interviewed a lot of the people involved in the Thorn EMI Liberator story. So if you refer back to that, then, you know, I think the title of the article in the Register is Liberator, the first British laptop. And it's a really well written piece, and it fills in a lot of the gaps. From my perspective, they'd approached Dragon with a view to developing, actually no, I wish I could remember exactly the order in which it happened, but the upshot was that the development team, a large percentage of and it wasn't a large development team in Dragon Data at the time, but because of the difficulties Dragon was going through, then we had to look for other opportunities. And Thorn EMI had been in negotiation with the CCTA, which was, at the time was a sort of civil service procurement for IT department. So essentially, they wanted in essence, a word processor that they could give to civil servants so they could immediately take it around with them and you know, write up their reports and so on. So it's very much a dedicated machine. And so the CCTA had approached various people, Thorn EMI had picked up on it. And again, I'm not quite sure if that was because of the Dragon connection and the technical director at the time, Derek Williams. But the upshot was that Thorn EMI took on board about 5 of us. We were relocated within Wales to Treorchy, where they had a factory. So those of us that lived in sort of Swansea, Bridgend, around about that area where obviously Dragon was, would have to drive over the Welsh hills to Treorchy for our work. And we developed the Liberator. And it was a CPM machine. There were quite a few. There was a few Japanese type products there. I think Epson was one of them. And I know that the CCTA had approached, I think, Epson and said, could you develop something? And they said, yeah, probably take 18 months. That's my recollection.
Okay. Well, we'll come on to, that rest of that story for the next bit. Let's just talk about towards the end for Dragon, the machines, because so these machines here, we've got the Dragon 16, we've got the Alpha there, the prototype which became the 32, the Dragon 16 became the 32. But there was also a Dragon Professional, so later on,
there was, yes.
It kind of, again, similar kind of story to Acorn, where, you know, and probably a lot of these home computer companies are starting to look for new markets in the professional world of computing rather than home computing. So Dragon also produced a Dragon Professional aimed at that kind of market, right?
3.5-inch discs on it, which was quite unusual, an early adopter of 3.5-inch discs, running the OS 9 operating system. And the software you could get for that, things like StyleGraph and Dynacalc, so word processor, spreadsheet. And OS 9 is a really nice, well-crafted operating system, very accomplished, and a nice marriage of the 6809s. and OS9.
Did OS9 only run on 6809s?
No, the 68,000 version of OS9 as well. But given, if you think about 6809, not particularly highly powered, not an awful lot of memory.
No.
So to have an operating system that is multitasking, very Unix-like, in operation inspired, I think, by Unix. Yeah, very impressive.
That is a very impressive piece of code to run on the 6809 and be multi-user. But it was kind of a little bit late in the day. There was other companies coming along.
Yes, I think so.
And which is the same story as
so I think
much every other home computer
in the Dragon meetup, there's what, 3 of the Dragon professionals.
Yep.
That's probably about 25% of
the ones that finally exist.
Yeah.
Ones that were ever produced, or the ones that actually now exist now.
Again, I'm not too au fait because the production of that would probably happen after I left Dragon.
Well, I mean, thank you very much for bringing these into the Dragon day today. It's incredible to see something as rare as a prototype. For
the very first prototype of any computer is always very special.
Absolutely, and particularly special to have it here today. So thank you very much for your time, for coming in and telling us about these machines. Okay. But we will be doing another video, actually right now, but you'll see it a little bit later, on the Thorn EMI Liberator. So thanks for watching, and thanks for coming.
Okay.
Thank you very much.
Thank
Cheers.
You.